interpretation of possible provenance and the tectonic setting of the provenance. So two goals, that is the provenance and tectonic setting of the provenance. Can sandstone composition lead us to the provenance and the tectonic setting of the provenance? This is the question. This is actually the question. Now, you see the sandstone composition, particularly the framework component, the mineral constitution, they to a large extent, they give us an idea about the provenance. Suppose I get potash feldspar. I get alkali or potash feldspar. Now, what if I get a potash feldspar? What does it indicate? It indicates that the sediment is actually coming from an alkaline plutonic rock. Alkaline plutonic rock. I am talking about potash feldspar. Alkaline plutonic rock, or it may be a low-grade metamorphic rock. If I get a potash feldspar, suppose I am getting soda feldspar. Soda feldspar. Now, what kind of rock the soda feldspar that is talking about? I am getting alkaline volcanic rock. Alkaline volcanic rock. Then you get the soda feldspar more. So if I get a soda feldspar, or I have a calcic feldspar, Ca feldspar, then what it actually talks about? It talks about a basic volcanic rock. So you see the type of feldspar. Potash feldspar, then you talk about a plutonic alkaline rock or a low-grade metamorphic rock. A soda feldspar, then you talk about a alkaline volcanic rock. And when you are basically getting a calcic feldspar, you talk about the basic volcanic rock. So a feldspar as such, it is an indicative that what kind of original rock that is supplying the feldspar. Similarly, quartz. This is also a very good indicator. Quartz is very good indicator. You see, when you get the polycrystalline quartz, so if I get a polycrystalline, you understand what is polycrystalline? There is monocrystalline quartz and polycrystalline quartz. In case of polycrystalline quartz, the quartz constitutes of a number of small crystals within it, which is polycrystalline. We will show that polycrystalline quartz in our microscope. There is no chance of showing you microscope. Let us see how best we can justify the absence of microscope. Now, quartz, in case of polycrystalline quartz, if you have the grains, the quartz grains, they have a extinction angle more than 5 degrees. If you have the quartz, which has a quartz normally kya hota hai? It gives you straight extinction. But here, if you get a extinction angle more than 5 degrees and the quartz is constituted of more than 3 subgrain, a quartz grain which has more than 3 subgrain. I write it also. Quartz grain with more than 3 subgrain and extinction more than 5 degrees. Then it is low rank metamorphic rock. Low rank metamorphic rock. You will also see that polycrystalline quartz supplied from low grade metamorphic rock, the subgrains, they are elongated. They are elongated and they show some kind of a fabric. That is also seen in some of these cases. Whereas quartz grains with less than 3 subgrain, then we consider it is the alkaline plutonic rock or high grade metamorphic rock. So this is famous work of Basu. Abhijit Basu in 1975. Basu and Dickinson. Famous work of Abhijit Basu and Dickinson. They actually considered that how to distinguish the original provenance of sediment based on the character of quartz grain. This is a famous one. And they identified, they have actually, this is a empirical relationship. They have taken samples from several hundreds and thousands of localities. They watched it under microscope, and this relationship they have found, that if you have more than 3 subgrain and the extinction angle more than 5 degrees, that means it is derived from the low rank metamorphic rock. Or if you have less than 3 subgrain, then is the alkaline plutonic rock or high grade metamorphic. This is a criteria. Also, the heavy mineral. What is heavy mineral? Which has specific gravity more than 2.74. That is, in the normal temperature, it is more than that of bromoform. That heavy mineral assemblage also a very good indicator. Suppose I have zircon, I just write zircon, hornblende, apatite, monazite, this kind of a assemblage. It clearly shows that you are basically getting it, or you can also have rutile topaz. This kind of a situation, that means your sediment is derived from a alkaline plutonic rock, granitic source, alkaline plutonic rock, granitic source, alkaline plutonic rock. If you have a heavy mineral assemblage, something like this, or I have a heavy mineral assemblage which is like this, diopside, enstatite, mica, pyroxene. Actually, diopside, enstatite, they are also pyroxene. It is, I should say, amphibole. You get this kind of thing. Then you consider that it is actually derived from a basic rock. It is derived from a basic rock, or it is derived from a metabasic rock. Basic or metabasic rock. So all these criteria. Similarly, feldspar, the character of feldspar, that also helps us. How? If I have large angular feldspar, that means the sediment is derived from a terrain of high topography and high erosion. The large angular feldspar, they basically talk about a terrain where it is a high topography and large scale erosion. Whereas a small feldspar with rounded shape, that basically talk about a humid climate with rolling topography. So humid climate, rolling topography, that will result in the small rounded feldspar, or large angular feldspar. They basically talk about the high topography and high erosion, and it may be at cases aridity of the climate also. Now, this is about the sandstone composition and how we interpret the different kind of provenance. Now, people also was bothered about the tectonic setting, and the, Dickinson and Sukhjek, SUCZDK, Sukhjek. These are the people who actually give a kind of model that how sandstone composition that can be related to different tectonic setting. And they identified three different tectonic. One, continental block. I will just draw it and show you. So Dickinson and Subject, they came out these three tectonic setting. Number one, you can draw it. Can you see the paper?
Yes, sir.
Hmm. Please let me know when the drawing is complete.
सर प्लीज थोड़ा ऊपर कर दीजिए नीचे का देखिए
सर 1 मिनट, मैं थोड़ा फैन स्लो कर देता हूँ. फैन फैन स्लो नहीं करने से मुश्किल हो रहा है. Is it done?
Yes, sir.
Okay. So what is shown that they actually identified that there are three. First one, I just forgot to write. It is continental block. You please write after continental block model. Second is recycled orogen. Third is magmatic arc. And they said that there will be some characteristic pattern of the sandstone composition. What will be the composition of the continental block? They said that it will be quartz rich. You can write quartz rich. Feldspar should be alkali feldspar, potash feldspar. So potash feldspar rich, sodic feldspar will be very, very less. You will not get much sodic feldspar. Quartz by feldspar ratio is high. And you will only get some plutonic or sedimentary rock fragment, but the proportion of the lithic fragment will be very, very less. So what are the characters? Quartz rich, alkali feldspar rich, high quartz by feldspar ratio, and subordinate sedimentary and plutonic rock fragment. This is the character of the continental block. Now coming on to the recycled orogen. What kind of? Now recycled orogen, as the model, the diagram shows, there is a kind of docking. Now the docking can be two types. It can be a docking between two continents or a docking between a continent and a magmatic arc. There are two kinds of docking I can think of. Now, if all these, they are basically the recycled orogen. Now, if you have the continent recycled orogen, then you will have the quartz rich and potash feldspar high, potash feldspar by sodic feldspar ratio high, and you get some plutonic and sedimentary rock fragment. Am I clear what I have said? Quartz rich, nearly similar to the continental block, but only thing is that lithic fragment percentage will increase. Lithic fragment percentage is increased, and you will get plutonic and sedimentary lithic fragment. Okay, but if there is a continent arc, that kind of a recycled orogen, then you start getting the volcanic rock fragment. When the arc is coming, then you start getting the volcanic rock fragment. The sodic feldspar percentage also increases, and you get the volcanic and metavolcanic fragments, sedimentary and volcanic fragment, that will come when you have a continent that is actually docking with a magmatic arc. So magmatic arc, it will start supplying the volcanic fragment. And as it is a magmatic arc, so you will also start getting the mode of the potash soda feldspar. Am I clear? You also may get the presence of the ultramafic fragment, ultramafic rocks. You can get some carbonate fragment. So all kind of lithic fragment that you can get. Then coming on to the magmatic arc. Now this is a system where you will hardly get any quartz or potash feldspar. You will not get any quartz and potash feldspar. What you will be getting? You will be getting the lithic fragment constituting of volcanic lithic fragment, carbonate lithic fragment, oceanic sediment lithic fragment. All these lithic fragments that you will get, you will not get quartz and feldspar. You will not get quartz and feldspar. All these, that is derived either from the accretionary prism or from the volcanic arc. So what I should expect from accretionary prism? Accretionary prism, that is the outer arc, I should expect the presence of ophiolite fragment. I should get the carbonate fragment. I should get the radiolarian chart fragment. All these, they are the part of the ophiolite, and they form the accretionary prism. That is the magmatic arc associated with, and the volcanic arc that will be the andesitic, mostly andesitic, and you get the large number of the volcanic rock fragments. So you can understand that there are distinct difference between a continental block, then a recycled orogen, and a magmatic arc. What is the fundamental? The continental block, more quartz feldspar rich. Continent recycling, quartz feldspar rich. Continent arc recycling, quartz soda feldspar increases, the volcanic fragment increases, and all these. Then the magmatic arc, no quartz, no feldspar. You are basically getting all the ophiolitic fragment, that is the ultramafic rock fragment, carbonate fragment, and then you also get the volcanic fragment from the arc volcanics. Now this they try to do in terms of a diagram. If you don't understand anything, then please ask me. This is the Dickinson-Subject famous tectonics and sandstone composition diagram. Please let me know if it is prepared down.
Sir, what is written below a transitional arc?
Transitional undissected arc. Undissected arc.
Okay.
I will explain what I mean by undissected arc, dissected arc. I will explain.
Done.
Okay. Just I take 1 minute leave. I am coming and then I am describing it. Acha, do you have any course of Professor Pant?
Yes, sir.
Which course?
Metamorphic petrology.
Actually,
Metamorphic technology.
yeah. He is in a very bad shape actually. Is the class going on?
No, sir.
Uh, because the thing is that he is in a very bad shape. He even cannot sit. He is so ill. Do you know that? Do you know
No,
that?
sir.
No, sir.
He was just 3-4 days back. Actually, I got a phone call in the morning, and you will not believe what was our condition. And we were fanatically searching for a bed for him, but we could not get a single bed. Almighty helped us that he in home we could provide some sort of medical help to him, and he is now little stable, and all of us should pray for his quick recovery. And he is in a very bad shape now. He is forget about taking class. He cannot sit, he cannot eat. That is his condition. So what I think, because I don't think he will be able to take class in another month. There is no chance because and he should not take also. If he takes any advice of any doctor, he should not take class for another 1 to 2 months. Because I know taking class of 1.5 hour, how much toll it takes on your health. He is not in a position to be at that. So I will talk with Anindita madam because she is associated with Professor Pant in this course, and you people have already taken a course from Anindita madam.
Yes, sir.
Yes, sir.
So I will request her, and you people also coordinate with her. I will also discuss with HOD, and I will talk with Anindita. So let me do all this exercise, talking with HOD and talking with Anindita madam, and then I will write in our group that I have already talked. You people contact with Anindita madam for initiation of the metamorphic class. Okay.
Okay, sir.
Okay, sir.
But it suddenly came to my mind that definitely metamorphic course is not being taken, and it is not possible for him. Absolutely not possible for him. He is not that. Even now, he is very bad shape. Anyway, I am now coming to this figure. This is a quartz feldspar lithic fragment figure, and what is shown here, the recycled orogen, on the left side where the uplifted basement, transitional craton, these are actually continental block. All three on the left side, they actually belong to continental block. Continental block, if you have the basement is uplifted, you have the enormous supply of feldspar. Because it is a basement uplift means that it is a tectonically agile, and the basement is actually a granitic basement, gneissic basement, granitic basement. So a lot of potash feldspar. If there is a little less feldspar and more of quartz, that means it is a stabilized craton. It is a stabilized craton, not that much of tectonically agile craton. And accordingly, the quartz content increases. Now I am moving towards right. You see the topmost is recycled orogen. Now recycled orogen, as I discussed, if it is a continent recycled orogen, then you again also get large amount of quartz. That I have already discussed. And you also get both feldspar and lithic fragment. That what we have already discussed in our lithic fragment. When you have a continent magmatic arc, that is the recycling, then you get more of lithic fragment. If it is a continent recycling, you get more of feldspar. Okay. Now coming on to this undissected arc, transitional arc, and dissected arc. Now what is that? This is actually, they are talking about the magmatic arc setting. Now undissected arc, that means you have a formation of an arc, which I have just drawn. You have a outer arc, you have a inner arc, you have a foreland, and then in that case, your lithic fragment, you have a large amount of lithic fragment. Feldspar and quartz is very, very less. You see, undissected arc, it almost contains no quartz feldspar. You have a huge, profusely present lithic fragment. That is the part where you have the undissected arc. Now, your arc that is getting more weathered, and the upper portion of the arc is getting removed, and the deeper portion of the arc that is getting exposed. That is what is dissected arc. That means an arc which is largely at the top part that is dissected, and the deeper root portion of the arc is exposed. And if the root portion is exposed, then again the quartz feldspar, they increase in volume. Because the deeper portion, it is a granitic. The upper portion, it is an andesitic. So when you have dissected the arc and exposed the root of the arc, then you again increase the quartz and feldspar. So there are fantastic work where people through the petrography, they have identified the ancient dissection of an arc system. That the arc is formed and the arc was dissected, the root was exposed, and how the petrography of the sandstone that was changed. Am I clear? Is there any question? If there is no question, yeah, please.
Can you repeat, sir?
Which
one? An undissected arc.
Undissected arc, the figure which I have just drawn as a magmatic arc. That is the undissected arc, a normal arc, where you have a outer arc, which is called the accretionary prism, and the inner arc, that is a volcanic arc. So what you will expect, that I will expect the large amount of lithic fragment present there, either supplied from the inner arc or supplied from the outer arc or the accretionary prism in the form of the ultramafic rock fragment, carbonate fragment, shale fragment. All these, they are basically the lithic fragment. I will not get any quartz or feldspar. You see that it is totally in the side of the lithic fragment. There is hardly quartz or feldspar. So that is the kind of undissected arc. And now when I am dissecting, suppose you dissect the body of a person, what you do? You cut the skin, then cut the fat layer, cut the flesh, and then you find the inner, that is the all our inner, that different food tract, the respiratory tract. That is the dissection doctors do of the body of a human being to see the anatomy of the body. So similarly, a arc that is dissected, that means that the upper portion of the arc that is eroded and the root portion of the arc getting exposed, the dissected arc. So when you have dissected the arc, then the deeper portion that is containing the basement part, that is the quartz and feldspar, they again start coming. So initially you are getting the lithic fragment dominance. Dhire dhire kya hoga, that it will show dominance of quartz and feldspar instead of the lithic fragment. Am I clear?
Yes, sir. Thank you, sir.
Okay. So this is actually the what I thought of discussing about the sandstone composition, and from sandstone composition knowing about the provenance and also the tectonic setting of the sandstone. What are the relation between the sandstone composition and the tectonic setting, sandstone composition and the provenance? This is one topic that I thought of discussing. Now, after this, we will be so far what we have discussed the fundamentals of the sedimentology. Fundamentals of the sedimentology. Now, with this entire knowledge, we will be entering into the sedimentary environment. Sedimentary environment. Now, sedimentary environment, there are on the surface of the earth. On the surface of the earth, there are three major kinds of sedimentary environment. Number one, continental. Number two, transitional. And number three, marine. Okay, these are the three. In continental, I can have glacial, alluvial fan, fluvial, lacustrine, and desertic or aeolian. In case of transitional, I can have delta, I can have estuary, I can have tidal flat, I can have beach barrier bar, I can have chenier. And marine. Neritic, pelagic. So continental, transitional, and marine. In continental, I can have glacial, I can have alluvial fan, I can have fluvial, I can have lacustrine, I can have desertic or aeolian. All these, they are continental. Then transitional, that is delta, estuary, tidal flat, beach barrier bar, chenier, all these are the transitional. And in case of marine, you can have the neritic and pelagic, shale, slope, and deep basin. These are the environments on the surface of the earth. We cannot have any other kind of environment on the surface of the earth. Noted?
So what is written after deep in marine?
Marine, neritic and pelagic.
Sir, after deep, sorry.
Deep basin.
Oh.
Or open basin, whatever you say. Deep basin or open basin. I think you people have written it, isn't it?
Yes, sir. Yeah.
Okay. Now, these are the different environmental setting on the surface of the earth. Now, when we will be doing the environment, discussing the different sedimentary environment, that what kind of product is formed in different sedimentary environment, what kind of succession they make, which allow us to, because you see, as a sedimentologist, what you will be doing, you will be actually gathering your knowledge from the modern environment and extend that knowledge into the ancient rock succession. So present is the key to the past. This is the fundamental knowledge for any kind of sedimentological analysis. That present is the key to the past. So I am observing the modern environment. I am seeing the processes operating in the modern environment. I am seeing the products that are formed by those processes from the modern environment. And then I extend my knowledge to the ancient rock succession to interpret that what kind of environment would have been at the ancient past where that rock succession has been deposited. This not only help us in understanding the type of environment, it also help us in understanding the type of different kind of natural resources that may be associated with that. This is a primary goal for any kind of exercise which lead to the hydrocarbon exploration, coal exploration, and different kind of even the exploration for the phosphorite, the evaporite, the carbonate. So all these, they are basically related to the environmental analysis. Now, once we do the environmental analysis, there are certain things, the definition of which must be known to us. The first thing, what we will be discussing, that we always define a sedimentary facies. So always define a sedimentary facies. You will also come to know metamorphic facies. I am not going into the metamorphic facies. I am talking about the sedimentary facies. Now, what is a sedimentary facies? This definition should be very, very carefully listened, carefully noted, and carefully remembered throughout the life. What is, if you remain as a geologist, you want to work as a geologist, then this definition, what I will be giving now, should be remembered and listened carefully. What is a sediment? Is a rock body that has a distinctive physical, chemical, and biological character rock body. Has everybody written whatever I have said?
Yes, sir.
Yes, sir.
What I have said, that a sedimentary facies is a rock body, sedimentary rock body. That means it is, I am talking about sedimentary rock body, which has a characteristic physical, chemical, and biological character, and which is distinctive from its adjacent rock body. so that I am identifying it as a separate facies. Okay. Now, what are physical character? The grain size, color, grain sorting, skewness, all these are the physical characters of a sedimentary body. If it is a sandstone, if it is a carbonate, then the type of limestone as you see in the naked eye, color of the limestone, the major structures that you see, the suppose is stromatolitic limestone, plain laminated limestone, oolitic limestone. So all these are the physical characters. Fine. Coming on to the chemical character. Is a facies will have a characteristics major element, minor element, trace element, and isotopic character. So chemical means major, minor, trace, and isotopic character. And biological means the type of fossils that is present within that sediment. Any kind of fossil which is characteristic of that sediment. Suppose I am getting a continental sediment, I am getting a delta transitional sediment, and I am getting a deep marine sediment. So I will be getting the deep marine fossils within the deep marine, I will be getting the shallow marine fossils within the shallow marine, and I will be not getting any marine fossil, I will be getting the continental, the different kind of freshwater fossil in the continental sediment. So you see, there is a characteristic fossil content. And this is separable from the adjacent rock only. This is called a sedimentary facies. A definition should be in the mind for always, how I define a sedimentary facies. Now, question is that, suppose I am getting a sedimentary facies, and I am getting a sedimentary facies, suppose I am giving one example to you. Pyritifera's black shell. Pyritifera's black shell. Okay, a black shell which contains pyrite. What will be its interpretation? अब तुम लोग बताओ इसका interpretation क्या होगा? If I get a pyre, what I will interpret or infer if I get a pyritifera's black shell?
It should be deep marine.
No. This is the problem. This is exactly. Any other answer? I am telling you. Or anybody can answer it? No. Okay.
Reducing environment.
Yeah. She is more correct. What I should interpret that it is a, first of all, black shell. Shell means it is the low energy, and presence of pyrite that shows a reducing anoxic condition. A reducing anoxic low energy condition. That much I can interpret. Pyritifera's black shell, a reducing anoxic low energy condition. Now, where this reducing anoxic low energy condition can develop? As Drishti said, deep marine. Yes, in the deep marine it can form. It can form in a lagoon. It can form in a deep lacustrine condition as well. Anywhere, a anoxic, reducing, and low energy condition can appear. Do you agree with me or not?
Yes, sir.
Yes, sir.
So I cannot say by seeing a pyritifera's black shell that it is a product of deep marine. I cannot say. This is the problem of interpreting an environment based on a single facies. This is a problem of interpreting an environment based on a single facies. Suppose I get a cross-stratified sandstone. Now, what does it indicate? The cross-stratified sandstone क्या indicate करते हैं? बताओ। क्रॉस स्ट्रेटिफाइड सैंडस्टोन क्या इंडिकेट करते हैं? अरे चुप क्यों हो, बताओ ना। अरे इतना इतना ये करने से कैसे होगा, कुछ तो बताओ। Cross stratified sandstone that actually talks about that there is some bed form. There is some bed form, that bed forms are actually moving and transporting the sediment. That means there is a relatively higher energy situation where the sandstone is there and the sandstone is in the form of movement by means of movement of the bed form. And those bed forms, they have formed the cross stratifications in sandstone. That is a cross stratified sandstone. Now, this kind of condition where there is a sandstone and bed forms are moving and forming cross stratified sandstone, that kind of condition I can have in a fluvial, in a shallow marine, in a aeolian, in anywhere. The sandstone can move in the form of aeolian. Dunes are moving in the sand and they are forming cross stratified sandstone. A current flow in a river system, the sandstones are moving, they form cross stratified sandstone. Anywhere cross stratified sandstone is forming. But can it show that it is a particular environment? No. So there was a necessity. Then how we can talk about an environment? So people then say, no, a particular phasis cannot talk about any environment, but a suite of phasis types, a combination of phasis types, what we refer to as the phasis association, what we call phasis association. What is phasis association? A phasis association is a combination of phasis types which are genetically connected, refer to a phasis association. And that is indicative of an environment. I will give example. A combination of phasis types which are genetically connected. And that is actually will tell us about a environment. Now, suppose a pyritiferous black shell and it is connected with large scale cross stratified sandstone. A large scale cross stratified sandstone that is associated with, then I say, okay, it is actually a barrier bar lagoon system. Large scale cross stratification, the barrier bar, and associated with that the lagoon that is talking about. If I have a pyritiferous black shell which is containing the deep water fossil and associated with the carbonate or silty sandstone which talks about the marine condition, then I say, okay, I am getting this black shell in a deep marine condition. Or I have the cross-stratified, trap cross-stratified sandstone, poorly sorted sandstone, and associated with that I am getting the black shell. Then I talk about it is a fluvial lacustrine system where the black shell is forming. Associated with coal, I can have the coal, I can have the sheet earth, I can have the black shell with pyrite, and associated I have the poorly sorted cross-stratified sandstone. Then I talk about I am working in a fluvial condition, and in that, in a lacustrine shallow condition, I am getting this pyritiferous black shell. So only pyritiferous black shell will not talk about any environment, but a association with which it is associated, that basically talks about a particular environment. Is it clear?
Yes, sir.
Yes, sir.
Now, there are some premise. There are some premise that number one, the type of environment in nature, you can write, type of environment in nature is finite in number. Type of environment in nature is finite in number. It is not infinite. If it is infinite, then modeling is impossible. It is finite in number. Number two, type of phases is finite in number. These are the premises that these two are finite in number. And that if it is true that these two are finite in number, in that case, I can do certain kind of modeling. I can feel that yes, these are the phases which are finite in number. These are the environment, they are finite in number. And this is the combination of phases. That combination talks about this environment. Because we know there is a finite number of environment and phases, so the phases modeling that can be done. That can be done. Okay. Now, today we first start with the continental environment. Continental environment. We will start the continent. Now, as I have written, in the continental environment, you have glacial, you have alluvial fan, you have fluvial. I will first start with the alluvial fan. Alluvial fan, and I will discuss glacial at the last, because the glacial is such an environment where all other continental environment product that can be seen. A glacial, it includes fluvial, it includes lacustrine, glaciolacustrine. So it is a combination of different processes. So glacial I will discuss at the last. First start with the alluvial fan. Let me draw some diagrams and then I will be talking to you. First, I start with this diagram. What is a alluvial fan? Alluvial fan is a subaerial cone-shaped body, C-O-N-E, cone-shaped body, which forms at the base of a physiographic high. I repeat, alluvial fan is a subaerial cone-shaped sediment body that forms at the base of a physiographic high. Now, this physiographic high, it can be a fault plane, it can be a faulted surface, it can be a normal physiography or the topographic high, such as a hill, which is that one of the largest alluvial fan in the world is our Koshi fan, which you all know that Koshi fan, and those from Bihar, they know it better, that what the Koshi river does. And about 4 or 5 years back, there was a huge flood in the Koshi river, which have taken lots of life. What actually happens in a alluvial fan? If you have drawn it, then you tell me there are a lot of other diagrams also. Now in environment, there will be a lot of diagrams. You have to draw a lot of diagrams. Once it is done, please let me know. I will show other diagrams. I have also drawn 2 lines, AB and CD. One is the transverse profile, and the AB is transverse profile, CD is longitudinal profile. AB transverse profile and CD longitudinal profile. What the other things that I have shown, there are some lobes kind of thing that I have shown. I will discuss those in the later figures. Okay?
Yes, sir.
Now, these are the figures. That is AB, that is the transverse profile, that is a convex subprofile. That means in a transverse profile, you can see the depocenter of the alluvial fan that will be in the mid-axis. So if you go on all sides of the fan, then the sediment body that will be actually pinching out. They will be tapering out. From the central axis, it will be tapering out on all the sides. Because the main axis of sediment deposition will be the central axis. In the longitudinal profile, it will show a concave up profile. So the maximum thickness near to the physiographic high, and as you go away, the thickness of the body is reduces and giving it a concave up profile. That is what you get in the longitudinal profile. And when I will be adding to it the different kind of products, then the diagram, it comes like this, the different kind of products. I will discuss with you what are the different kind of products what we get. We will be discussing. You first draw it, I will discuss. I have also done the water table. I have written a point that is called equilibrium point. I have written, isn't it? Yes, equilibrium point. Please let me know if the drawing is complete.
So what is written beside mid fan?
Mid fan, then outer fan.
सर थोड़ा सा नीचे कर दीजिए.
Is it done?
Yes, sir.
Okay. So I start the discussion. First, start with the first figure. In the first figure, it is shown that at the base of a physiographic high, a fan is being formed, and the kind of slope which can trigger the formation of fan, and the kind of slope, it may vary from 1.5 to 25 degree. 1.5 to 25 degree. This kind of slope can trigger the formation of a fan. Okay. Now, the size of a fan, the type of phases distribution within a fan, all depend upon that at what climatic region the fan is forming. A fan forming in an equatorial region, a fan forming in a temperate region, they will not be similar in terms of their size and phases distribution pattern. Because all depends upon that how much is the water discharge your fan is getting. The more the water discharge in the fan, suppose you have an equatorial region and you have the large amount of Cauchy fan. Why it is the largest fan in the world? Because it is the equatorial fan. And it has the huge, during the rainy season, it has a huge discharge that the Cauchy River is bringing. But if you go to a temperate region, there is not much rainfall and the supply of sediment is less, so the fans formed are much smaller in size and they are more dominated by the mass flows, whereas the humid fan, they will be more dominated by the channel flow. What I said, that not only the size, the type of phases will be, I will explain it further, type of phases will also be varying. Okay. Now, if you see this figure, in this figure I have shown some lobes and I have shown some kind of the channel flow. So from this figure, it is clear that the two products, they dominate a fan. That is the mass flow and channel flow. Am I clear? Mass flow and channel flow. Now, mass flow, they can be in the form of debris flow, they can be in the form of mud flow, or they can be in the form of landslide. Mass flow, when we talk about, then we get the mass flow in a fan either in the form of debris flow. What is the product of debris flow? It is a matrix-rich conglomerate, which is a product of laminar flow. And this kind of conglomerates are very, very common in the alluvial fan, particularly in the proximal alluvial fan. Okay. If the mud content is high, that is more than 8%, then you call it a mud flow. You also get the landslide, that is the failure with respect to slope and the carriage of the sediment in the downslope by means of landslide. All these, they have a typical product that which is a very poorly sorted character, which is a very, very important character. And they are either the debris flow, mud flow. Then the next very important that is there, that you have the channel flow, which is also very important. Now, two types of channel flow we basically get in a fan. One is called the sieve deposit, SEIVE, sieve, SEIVE, and incise channel. Two types of deposit, sieve deposit and incise channel deposit. Two types. What is sieve deposit? Sieve deposit is that during the high flow stages in a fan, the sediment that in the form of a sheet that is spreaded on the surface of the fan. As the large size sediment, they like a sheet is spreaded on the surface of the fan by means of the sheet flow. In a sheet flow, the sediment, the coarse sediment is spreaded on the surface of the fan. This kind of flow, that is what we call the sheet flow, they form the sieve deposit. A typical characteristic of alluvial fan product. What is a sieve deposit? Sieve deposit finally is identified by the reverse graded pattern. A sieve deposit characteristically will have a reverse graded product. How? Because once you are spreading the sediment on the surface of the fan, the finer grain, they trickle through the opening of the larger grain and they form a, but the thickness of these deposits are very, very low. It is not very thick deposit, but if you find this sieve deposit, then it is a characteristic of a alluvial fan. Am I clear, or you want to know something about it?
The reverse graded product, सर एक बार दोबारा बता दीजिए. सर रिवर्स ग्रेडेड प्रोडक्ट एक बार दोबारा बता दीजिए.
What I am saying, that during high flow stages, a fan, it is bringing high flow stage. What does it mean? Suppose there is a heavy rain in the hinterland, heavy rain in the hinterland, heavy rain in the hills. So what will do? The Koshi River, it will bring large amount of sediment from the hill because of the high water stage. That is the high flow stage. And once it is coming out of the slope and it is at the base of slope, it is spreading the sediment all over the fan surface. Rather than carrying the sediment in the form of a channel, it is actually spreading the sediment on the surface. Now, because of the high flow stage and the sheet flow. Now, what will happen when you are spreading the sediment, then the coarser sediment will be spreaded, and between the coarser sediment, the finer sediment will trickle to the below. And that create a kind of reverse grading in the product. Am I clear?
Yes, sir.
Now, there is another, which is a channel flow, where you can define the boundary of the channel and there is a flow that is carrying the sediment. So in that is, we are referring here incise channel. Incise channel means which has a channel shape, and through that the water is flowing. Now that will be basically creating the different kind of bed forms, the trap cross stratified sandstone, planar carb cross stratified sandstone, and all these the poorly sorted sandstone in the form of cross stratification. Because in a channel there will be large number of bed forms, they will be moving. So that is the product of the channel. So what I have discussed, that the major product of a fan can be classified into two types. One is the mass flow, which constitutes the debris flow, mud flow, landslide, and the channel flow, which constitutes the sieve deposit and the incise channel deposit. They together form the alluvial fan. Now I come on to the other figures, the last figure that you have done. You see, the mass flows I have shown in the form of some lobes, and the channel flows, they are shown in the form of planar curved and the trap cross stratification. What is actually is shown in this figure, that you have a fan profile and there is water table. This water table is cutting the fan profile at a point what is referred to as the equilibrium point. Now, in the upslope part of the equilibrium point, what will happen? That water will not be allowed to stay on the surface because water table is below. So any water which is available on the surface of the fan in the upslope part of the equilibrium point, that water will always go down because the water table is below. Whereas in the downslope part of the equilibrium profile, because your fan slope is lower than the gradient of the water table, what will happen? That the water will happily stay on the surface of the fan. And if water happily stays on the surface of the fan, that will be in the form of channel flow. So you will hardly get any channel flow in the upslope part of the equilibrium point, and there will be dominance of the debris flow. Whereas in the downslope part of the equilibrium point, you will be getting more of the channel flow, and that is the demarcation of the inner fan and the middle fan. It is the domination of the channel flow in place of the mass flow that marks the mid fan part. It is not that you will not get the mass flow in the mid fan part. You can also get the mass flow in the mid fan part, but the domination will be always for the channel flow. Whereas in the inner fan part, the domination will also always be of the mass flow. Though channel flow will also be there, that will be subordinate. Am I clear? Is the thing clear to all of you?
Yes, sir.
Okay.
Yes, sir.
And what is the role the water table is actually performing? How water table is controlling the phases distribution on the fan? Water table is controlling the phases distribution in the fan. Now, in the further.
Sir,
बोलो.
सर क्लास है हमारी साइड.
हाँ?
सर क्लास है दूसरी. सर अभी 11:30 से.
11 अभी तो 11:25 है.
Yes, sir.
I'll take another 5 minutes. Now, further downslope, the river system, it may grade either to a lake or a marine system or a alluvial plain. So a lacustrine, that is the lake, that there you will be seeing that the river system, it will be, it all depends. If it is in a marine system, we call it a fan delta. If the alluvial fan that discharge into a marine system, that is a fan delta. If in normal cases that the alluvial fan that grade into a alluvial plain, a bed plain system. So anyway, you have a class. I know you should have 1-2 minutes for respite. So we will start our discussion in the next Thursday with this figure only, because it is not complete yet. Okay?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.